Boom.
All right, Julia, we're back on part 2. We're learning how to find the variance and then the standard deviation. Do you recall, do these words make sense to you? Variance and standard deviation? Do you remember if you had the variance, how you got the standard deviation? We took the square root of the variance, and that would give us the standard deviation. So I'm sure you knew that. The symbol for the variance of a random variable is going to be, we used to use, when we had data, we used S sub x like this. I'm going to erase it because that's not what it's called now. So what it is when we're looking at the variance of a random variable, it's going to be this sigma. Is that what it is? Is that a sigma? What is that?
Sigma.
Sigma sum x squared is the variance of a random variable. The variance. I put RV for random variable, and just sigma sub x is the standard deviation of a random variable. So that's a symbol we're going to use for those. Now all I have to do is tell you how to calculate it. It probably won't surprise you because it parallels what we've seen in the past. The variance, how far the data will vary from the mean, is going to be calculated by taking the data, x1, remember there are outcomes in the random variable, so I'm going to take the first one. I'm going to subtract from it the expected value, this value that you calculated, and then I'm going to square it. Does that look familiar? We did that before. And I think before we divided by something, the number of data points, I believe. But in this part, we multiply by the probability. Then we do it again with x2. U sub x squared probability 2
And mu
plus
sub x,
dot,
you're
dot.
just keeping that the same value.
What's that?
You're just keeping mu sub x the same
Yeah, because
value.
that is the one value. It's not different in each step. Alright, so would you go to Friday, it's a couple hours have gone by, we're calculating the variance for the cars sold on a Friday, first couple hours on a Friday. So can you use that formula with these numbers from this chart and this expected value to find the variance? Ignore me. If you need to, you can listen in. Ignore me if you don't need help doing that. X sub 1 is the first possible outcome, which is 0. This won't zero out this time. 0 minus the expected value we already calculated, 1.1, quantity squared, times the probability of that outcome, which is 0.3. That is the first iteration. Second one, we're going to add to that x sub 2, the second outcome possibility. So 1 minus expected value squared times its probability, 0.4 plus 2 minus 1.1 quantity squared times 0.2. Stop me if you have a question.
I don't understand.
We're following this formula,
Yeah.
and x sub 1 is the outcomes of the variables. This is the random variable outcomes. So the first one, this is my x sub 1, x sub 2, x sub 3, x sub 4. So you okay with that?
Okay.
Minus the expected value, which is what we calculated in the beginning of class. We already did that.
Okay.
And then I erased that, but we did it together. And probability 1, what's the probability of the first outcome? In the chart it's given as 0.3. So then we do that again. Second, now we have the outcome x sub 2 is 1 minus 1.1 squared times its probability, 0.4, and so on, and so on. So the last one is 3 minus 1.1 quantity squared times 0.1. So we get to tippy tap all of that out.
Oh wait, no. I just like about 3.6. That's the answer to my
Is. All right, we've got an answer on the floor that agreed with mine. Variance equals 0.89. If you didn't get that, don't sweat it, you tapped it in wrong. If you put these numbers, if you tried to put these numbers in and you got the wrong answer, don't worry with it, I'm sure it was something minor. The variance is 0.89. The variance is not what we really want though. We usually, in context, we want the standard deviation.
Why is the probability after the parentheses? Why is it before?
Why is it?
Yeah.
Why is it after? Why does it exist at all?
No, why is it? I don't know. It's just normally we have. It just looks weird after the parentheses.
Instead of before?
Yeah. Does that change it?
No. You can put it before if you want. All right. So we usually don't use the variance that much, but we use the standard deviation. So I already mentioned to get from the variance to the standard deviation, you take the square root. So somebody's square root 0.89. Square root of 0.89
is 0.94.
0.94. All right. So let's talk about that in context. What does a standard deviation mean in real world? In the real world with real words. So I'm going to actually write it out on the average. The number of cars sold on a Friday morning will differ from the mean, because that's what a variance and standard deviation are dealing with, their difference from the mean. Will differ from the mean, which we already know. In this case, I'll put 1.1 by 0.943 cars. All right. Well, I'm not comfortable with these decimal points of a car, but that's what it means statistically, so I apologize. All right. So far, I'll give you a pause where you write that down in context, so when you're asked to do it, you can look back at that as a good example. The standard deviation, this is standard deviation. The standard deviation of, what was it, 0.94. This is what it means. On the average, the number of cars sold on a Friday morning will differ from the mean by 0.943 cars. So. Oh. All right, let's look at.
That's a lot of cars compared to 1.1. So really,
I know. So there's
really
a very
like
big spread. You know how some distributions are like that. There's hardly any spread. This looks like a big spread.
Yeah.
So good point. I like that. All right. So far, what we've looked at is the fact that these are discrete. Can you look back in your notes or in your brain and tell me what we meant by discrete?
Discrete, random
There's
variable.
nothing in between.
Right, very good. Your brain came through. So it means you could have an outcome of 0 cars sold or 1, but not 1.1. Hey. Well, that's what it meant by discrete random variable. So we're going to put away discrete random variables and look at an example which is something different. I'll leave this part up and get rid of this part. We don't need this part. Alright, if you're still copying, I'll leave that part up for a little longer. Great.
Kayla needs help.
No, she's just.
Alright, we're going to go from, I guess I'll teach it by example. I want you to write this example down. I'm going to choose a random number, and that's what I'm trying to remember how to do on my calculator. Choose a random, I couldn't find it, so I'm in the same boat with you, Bailey. Choose a random number
Maybe
From-
someone still both about calculators.
0 to 1. So if I choose a random number between 0 and 1, how many possible outcomes are there? So we call that the sample space. Remember, the sample space is all the possible outcomes. Like in the one I just erased, there was 0, 1, 2, and 3 cars. That was all the possible outcomes. What are all the possible outcomes in this event? Choose a random number from 0 to 1. How many numbers are there between 0 and 1?
What kind of?
It's a discrete.
Any number.
So infinite.
Yeah, very good. So, can I list the numbers? Can I list all the numbers on the board?
No.
I cannot. So there's an infinite sample space, so I cannot list them. So you can see that we have graduated from a discrete case to a continuous random variable. So making a continuous random variable has an infinite number of outcomes, and I can't list them all. So it involves an interval. And so you can see the interval here is between 0 and 1. I cannot list all the numbers for you between 0 and 1 with their probabilities. So what do we do? How do we do these kind of problems? How can we find the expected value in the standard deviation? Well, we have to look at it differently. Suppose I draw for you a graph. So I'm picking the numbers from 0 to 1. And if I make a line at 1, I need my mathematicians to come out. Here's a probability density curve. What's the area under this curve, this thick line?
1.
All right, because it's 1 high, it's 1 long, it's a square. It's supposed to be a square. And the area is 1. If you recall, we've seen this before. Suppose we look at all the IQs. And most people have 100 IQ, and some people have a very high IQ, and some people have a very low IQ. But not as many people have the high IQ, and not as many have the low IQ. Do you recall what the area was under this?
1.
It was. You remember that. We've had that, the normal curve, the normal density curve
Ah! Ah!
has an area of 1
Calculus.
as well.
Ouch.
So that's how we're going to do these problems that are continuous. We're going to look at graphs where the area under the curve representing the problem is always 1 because it represents all the possibilities. So that's how we deal with continuous problems. We look at a graph. So let's say that I wanted to do this problem. So here's all the possible numbers between 0 and 1. I am not listing them with tick marks, but your mind can put in an infinite number between 0 and 1 because you have a beautiful mind that can do that.
Aww.
So what is the probability of picking a number? I'm going to use y for my continuous random variable. Often it is used, it's not required. I could have used an x. But let's say I use a y because it's a continuous random variable. And I want the probability of drawing a number between -3 and, not -3, 0.3 and 0.7.
It's been on for 40 minutes.
Okay,
Should we?
all right, down again. So what segment are we on now?
No, just stop.
Segment.